Hello guys, welcome back to Explore Biology. In this video, we are going to learn about a very important topic, that is cardiac cycle. We all know that heart is an important organ which pumps blood to all parts of the body. Pumping blood means it is sending oxygen to all parts of the body for survival. Let us see how exactly this occurs. In this cardiac cycle, we'll be hearing a common terms, that is systole and diastole. What exactly is a systole and what exactly is a diastole? Systole is nothing but contraction and diastole is nothing but relaxation. We know that heart is made up of which muscles? Cardiac muscles, right? So cardiac muscle will undergo contraction and relaxation. That terms we tell as systole and diastole. Now, if I ask, how can you define cardiac cycle? Then you can say that the cardiac events that occur from beginning of one heartbeat to the beginning of the next is called a cardiac cycle. That means the duration from the first heartbeat to the second heartbeat, starting of the second heartbeat, this duration is cardiac cycle. Okay, cardiac cycle, right? Now, before going into the detailed information about cardiac cycle, first let us have a brief introduction about its structure. Okay, so we know that human heart is made up of how many chambers? We have 4 chambers, right? So this is right atrium, then we have left atrium, right? Then we have right ventricle and we have left ventricle. Left ventricle is a bit thinner than the right because of the presence of thicker cardiac muscle. Okay, and we have opening between the atrium and ventricle which are guarded by valves. Okay, so this is right, left, right and left. The valve which is guarding the right side, atria and ventricle, this valve is known as tricuspid valve. Tricuspid valve. And the valve which is present at the left side, this is known as bicuspid valve. Okay. Bicuspid is also known as mitral valve. Mitral valve. We have openings on the right atrium, superior and inferior vena cava, and also in the left side we have pulmonary veins. And in right ventricle we have opening of pulmonary trunk, and on left side we have aorta. That means the blood, the deoxygenated blood is coming from different organs into the heart through superior vena cava and also through inferior vena cava. And later on it is carried into the right ventricle, and from right ventricle it is going to the pulmonary trunk which is going to lungs. Okay, so we have lungs here and here we have different organs, right? Now in lungs what happens? Exchange of gases occurs, right? This deoxygenated blood is converted into oxygenated blood and is coming to the left atrium through pulmonary veins. From there it comes to the left ventricle and goes through aorta. Now this aorta, what it is doing? It is pumping blood to all parts of the body, right? In organs again there will be exchange of gases and again deoxygenated blood is coming to the heart. So in general, if you say human heart is having double circulation, okay, we have double circulation. Why we are saying double circulation? Because blood is transported to the heart twice, right? From lungs to heart, from organs to heart, right? 2 times. This is double circulation. So these are the basic things, or you can see the basic structure and where exactly the blood is flowing. Okay. Now let us come to the cardiac cycle. So for our understanding, we divided the cardiac cycle into 3 different stages. Okay. Heart doesn't know that it has 3 stages. It is just for our convenience that we can understand how exactly the events are. So the first one is joint diastole. Next we have atrial systole, and then we have ventricular systole. The total duration of one cardiac cycle is 0.8 seconds. Okay. If you see heart, human heart is a bit complicated. Okay. In humans, the heart is termed as myogenic. So there are 2 different terms for heart, myogenic and neurogenic. Neuro is the term used for nerves, right? So here the heartbeat is under the control of nerves. But myogenic, the heart can stimulate or it can send signals to itself. This is because of special tissue known as nodal tissues. So these nodal tissues are present in humans, which is making human heart myogenic in nature. What are those? Let us see. So we know this is right atrium, left atrium, right ventricle and left ventricle. Okay. Just in the right atrium at the top, we have one nodal tissue which is known as sinoatrial node. Okay. The first one is sinoatrial node. Sinoatrial node is considered as the pacemaker of heart. Pacemaker of heart. That means it is helping in maintaining a number of beats per minute. Okay. Sinoatrial node have a capacity to make 100 beats per minute, but it is controlled by parasympathetic nerves. Parasympathetic nerves, which is maintaining it for 72 beats per minute. Okay. Usually it can beat for 100 times, but it is regulated by parasympathetic nerves. Coming to the second special nodal tissue, which is present near the septum. This is AV node. Okay. The second one is atrioventricular node. Okay. Atrioventricular node. The next we have is bundle of His. Bundle of His. And this bundle of His will branch into Purkinje fibers. Purkinje fibers. So we have bundle of His, and next we have Purkinje fibers. Okay. So these are the nodal tissues which are responsible for the contraction and relaxation of muscles inside the heart. Okay. Let us see the actual cardiac cycle, starting with the first phase, that is joint diastole. Diastole means what I said, it is relaxation. Okay. Joint diastole means both atria and ventricle are in relaxation condition. Okay. Both atria and ventricle are relaxed. So we have both in a relaxed condition. Okay. So we have atria. If you see this diagram, so this is right atrium, right ventricle, left atrium and left ventricle. Right. Now, blood is coming from the lungs into left atrium, from different organs into right atrium, right? As the valves are open, see in the relaxed conditions, all the valves are open, okay? Valves are open, okay? That too, atrioventricular valves, not semilunar valves, okay? Now, as soon as blood is coming into the atrium, immediately valves are open. So, what happens? It goes to the ventricles, right? Now, here what is happening? Ventricular filling is happening, right? Ventricular filling, right? Because the valves are open. So, the blood which is coming from the pulmonary veins, it is entering into the left atrium and directly it is going to ventricle. The same with right atrium, blood coming from superior vena cava and inferior vena cava. It is going from atrium to the ventricle. Okay. 80% of blood is filled in ventricle through relaxation condition. Okay. Now, slowly what happens? We have sinoatrial node which starts sending stimulation to the atrium, right? When this atria, the total muscles in the atrium receives the signal and they undergo depolarization, that will lead to the next stage, that is atrial systole. Okay, that is atrial systole. So when there is complete depolarization, what happens? The atria will undergo contraction. Okay. When atria will undergo contraction, we call it as atrial systole. See, initially 80% of blood has entered into the ventricle, right? Now, through atrial systole, another 20% of blood is going into ventricles. Okay. So, initially it was open. So, what is happening? Filling was done, right? Ventricles are filled with blood. How much? 80% is totally filled. Now, as the depolarization has started from the sinoatrial node, now when this depolarization is complete, then what happens? Contraction occurs, which is atrial systole. Now, this atrial systole will push again 20% of blood. See, now atria will contract. Well, it comes closer, right? So, it will compress and send the blood to the ventricles. How much extra blood is going? 20% extra blood is going through atrial systole, right? Now, the total blood which is present inside the ventricles is approximately 110 to 120 ml. Okay, which is approximately 110 to 120 ml, which is collected inside the ventricles after joint diastole. That is the reason why we call it as end diastolic volume 110 ml to 120. So after the completion of joint diastole, how much blood is present inside the ventricles? 110 to 120 ml, which is considered as end diastolic volume. Okay. So the first step, joint diastole, is done, which is followed by atrial systole. Now during atrial systole, what happened? Blood from atria has entered into ventricle. When blood has entered, the pressure inside the ventricle have increased. As the pressure inside the ventricle increased, the valves are open, right? Due to this increase in pressure, it pushed the valves. Now the valves will get closed. Okay. So due to the increased pressure inside ventricles, what is happening? Valves get, which valves? AV valves. AV valves get closed. So because of the high pressure, this valves will be closed with a strong push. That push gives a peculiar sound known as love. Okay. Lub is the first heart sound you can hear after atrial systole, which is first heart sound, right? When you will hear lub, when there is increase in the pressure inside the ventricle, it pushes the valves which goes to close, right? Which gets closed and we hear lub. Now, semilunar valves are closed, AV valves are closed, right? Inside the ventricle, the volume is same, that is 120 ml. 120 ml, right? So this is isovolumetric, okay? Isovolumetric, right? Isovolumetric condition, that means see, valves are closed and volume inside the ventricle is same, right? So this is isovolumetric condition, right? Now, as the pressure inside this ventricle is increased, see now the signals which have entered into the atrium, it has reached the atrioventricular node. Now it is going to the bundle of His and it is going to the Purkinje fibers, right? Slowly. Now as it reaches the Purkinje fibers, what happens? Now the ventricles will start depolarizing, right? As the ventricles will start depolarizing, what happens? The ventricles will contract. So pressure inside the ventricle increases, which exceeds the pressure inside pulmonary vein and aorta. So here the pressure will be low. The pressure here will exceed the pressure inside this. What happens? We'll open this valves. Now, as the signals reach the ventricles, what happens? It continues as ventricle contraction. That means ventricular systole. The next step. What exactly happens here? So when there is increase inside the pressure here inside the aorta and pulmonary vein will decrease when compared to here. So what happens? It will open up the semilunar valves and in turn what happens? Depolarization of ventricles occur, which will lead to ventricular systole. As the ventricular systole occurs, what happens? Now the ventricles will get contracted and it pushes the blood into aorta and this pulmonary trunk, right? Now blood is transferred to aorta and pulmonary trunk. Now when the pressure here, see now what happens inside from the ventricles, the blood is pumped into the aorta. Now what happens when liquid is entering here? It pushes the walls, right? It creates the pressure, right? Due to the increased pressure, now what happens? The semilunar valves will get closed. The semilunar valves will get closed. Now you can hear the second heart sound, that is dub. The second heart sound dub you can hear here, right? So when the semilunar valves get closed after the ventricular systole, then we call it as dub. The second heart sound. Second heart sound, right? Now semilunar valves will get closed and AV valves are already closed. This closure of all this and the pumping of blood, right? Now here the volume is same again. How much blood it is pumping? It is pumping 70 ml. Initially how much it was there, and diastolic volume it was 120 ml. From that 70 ml is pumped into the pulmonary trunk and also aorta, right? Now how much will be remaining? 120 minus 70, it will be how much? 110 minus 70, 120 minus 70, approximately 40 to 50 ml, right? Approximately, right? 40 to 50 ml. Now, the 70 ml which is pumped into the aorta and the pulmonary trunk is known as stroke volume. Okay, stroke volume is 70 ml. Right, see, the three stages are already done. Joint diastole, atrial systole and ventricular systole. A complete cycle is done. So for one complete cycle, how much amount of blood is pumped? 70 ml. That means for 0.8 seconds, 70 ml of blood is pumped from the heart. Okay. If you see here, for your easy understanding, the one which we have drawn. See, the first one, joint diastole, both are at resting condition, right? Now, depolarization have started in atria, which leads to atrial systole, right? Then depolarization goes to ventricles and then causes ventricular systole. So, after ventricular systole, how much blood is pumped? 70 ml of blood, right? From aorta, where it is going to different parts, and from pulmonary trunk it is going to lungs, right? So 70 ml is pumped from the ventricles. For one complete cycle, we have how much stroke volume? That is 70 ml, right? Now again here the valves are closed, the volume is same, right? 40 to 50 ml we said, right? It is present inside the ventricle. This is also isovolumetric condition, right? This is isovolumetric systole and this is isovolumetric diastole, right? Because here isovolumetric is in the diastolic stage and here we have in the systolic stage, right? So isovolumetric systole and isovolumetric diastole conditions. Okay, the overview of the cycle. So what exactly happened? Both were at resting condition in joint diastole, right? In joint diastole, both were at resting stage. So what happened? Filling has started, right? Here semilunar valves are closed. Now, as the depolarization have started from the sinoatrial node, now slowly what happens? All the muscles in atria will get depolarized. Okay, depolarization. Depolarization will cause what? Atrial contraction. Now contraction of atria have again pumped an extra blood. So initially it was 80%. After contraction another 20% is being pumped. So 100% is pumped, right? Isovolumetric systole, right? Next. So after the entry of the blood into ventricle, pressure have increased. Due to the increased pressure, valves got closed, right? This will give lump sum. Next. Now the ventricle is totally filled. The pressure here is increasing and the pressure here is decreasing. Now what happens? The valves will get opened and the blood is pumped into the pulmonary trunk and aorta, right? Now in turn the depolarization is started right here. So ventricles will contract and push the blood into pulmonary trunk and aorta, which will cause ventricular contraction, right? Now as the pressure here is decreasing and inside the pulmonary trunk and aorta is increasing, pressure is increasing. So what happens? The semilunar valves will get closed. So closure of semilunar valves will here done. This is isovolumetric diastole. Okay. So here the ventricles are at resting condition. We call it as diastolic condition. And here the ventricles are starting the contraction. So we are saying isovolumetric systole. So starting isovolumetric of systole and here starting of diastole, we call it as isovolumetric diastole. So this is about the complete cardiac cycle. Now let us calculate the output. Okay. So cardiac output is very important. Cardiac output. How can we calculate the amount of blood pumped per 1 minute? Stroke volume into number of beats per minute. Okay, so stroke volume is how much? 70 ml we say, into how many beats? 72 beats per minute, right? So 70 into 72, approximately 45040 ml, that is 5 liters per minute. So our body, our heart pumps how much? 5 liters per minute, right? So this is cardiac output. If we say 100 beats, again you can calculate for 100 beats, right? So you need to know the formula here. Cardiac output is equal to stroke volume into number of beats per minute. Okay, so this is about the cardiac cycle. Here one more thing to remember, okay, they can ask questions like this. Like, see, when you can hear two heart sounds, after atrial systole, you can hear lub, right, due to the closure of AV valves, and after ventricular systole, you can hear dub, right, due to closure of semilunar valves. From one lub to the next dub, is 0.3 seconds. For next dub, from one dub to the next lub, it is 0.4 plus 0.1, that is 0.5 seconds. Okay, so from in one cardiac cycle, the duration between lub and dub is 0.3. From first dub to the next lub will be 0.5 seconds. Okay, so this you can calculate using this pie diagram, right?
If you think this video is useful for you, please like, share and subscribe to my channel Explore Biology. Do follow me on Instagram for more updates. Thank you.